Hey mathematicians, here are your notes for 8.4 talking about polynomials. So let's start off with the bell work. How do we know a monomial is simplified? Well, if we think back to multiplying and dividing, simplified just meant that there was only that one variable. There wasn't one variable on the top and the bottom of a fraction. There wasn't two right next to each other, like x times x squared would not be simplified. So essentially we know a monomial is simplified when there's only that single variable, meaning we've simplified each variable to its simplest exponential form, but also when there is no negative or zero exponents, That's really important to realize. No negative or zero exponents. Today we're going to switch gears a little bit and we're going to be able to differentiate, meaning tell the difference between polynomials as well as determine the degree of polynomials. So go ahead, start off right here with that what I think section, and go ahead and we'll get back together in just a minute. All right, hopefully you had a second to just look at those words and tell me what you think they mean. Let's jump to the what I know section. So for those of you who don't know this previously, mono means one, and nomial, or just meal there, essentially is saying term or number. So when we have a monomial, we have a one-term math expression. So one-term expression. A binomial then, much like a bicycle, has two-term expression. And two-term doesn't mean two variable. It means two distinct ideas separated by addition or subtraction. You can think of this one like a monocycle, single tire. And then a trinomial, much like a tricycle, is a three-term expression, and you can kind of see what direction this is going in. However, after we get three terms, it becomes a little bit messy. So anything over three terms is going to be a polynomial. Now, poly means many. So a polynomial means a many-term expression, in our case, 3 or 4 plus. Now, how are they related? Well, they all talk about terms like x to the third y would be an example of a monomial. As soon as we add or subtract a second term, it doesn't matter if it's a number or a variable, we suddenly have a binomial as soon as we add that second term. Now, when I'm differentiating, I like to draw these little lines underneath. So let's do x plus y minus 2. Notice x is a single term, positive y is a single term, and negative 2 is a single term. So that would have 3 pieces, making it a trinomial. So now the question is, can we tell the difference? Let's identify each of the following as a mono, a bi, a tri, or a none. Now, one other thing before we jump in, and probably something I should have put in this box, is the idea that everything with one or more is technically a poly. Poly is the overarching term for the mono, bi, and tri. So if something's a trinomial, it's automatically a polynomial. If something's a binomial, it's automatically a polynomial. It's just an overarching term we use for these expressions. So let's go ahead and jump into it. 36, I'm going to draw my little expression underneath, and I know that this is only one term, so this is going to be a polynomial, specifically a monomial. Second one is a little tricky. Take a look at it there. If I go ahead and simplify this, I see that the q squared is already on the bottom, but if I rewrite this, I get 3q to the negative 2 plus 5. Now, those negative exponents those are a problem for me. And even in simplified form, this is not any of the following. You'd think that it was a binomial, but due to this negative term on top, or this division on the bottom, this is none. This is not any of the following. We have to have no negative exponents and no variables in that denominator. Same thing here. All right, we've got a single term, second term, third term, making this a trinomial. Keep drawing those lines underneath to help you. Notice the sign goes with it. So this negative 7g times h, that negative is part of that term. Same thing here. Positive 2 is part of that term. You got 3 terms going on. It's a trinomial. All right, and then last one, let's go ahead and put this into the proper form to get it all on that one line. Just like problem 2, that negative is going to cause an issue, and this would be none. So we can not only differentiate based on how many terms they have, but we can also talk about the size of those terms. And the size is called the degree. So the degree of a monomial or the degree of a polynomial are their sizes. Now in this what I think section, I want you to try and tell me what you think the difference is. How do we define the size of a monomial, one term, versus a polynomial, more than one term? All right, hopefully you had a minute to think about that. The degree of a monomial is just going to be the sum of its exponents, its variable exponents. Okay, and before I jump to the second definition, let's go ahead and do this one right here. I've got x squared, I've got y to the third, and I've got z technically to the first. Remember, there's always an exponent even if they don't write it. So my degree of this monomial would be 2 plus 3 plus 1, which would be 6. Notice, I don't include the 4 because it is not a variable exponent. It's a numerical exponent, so we ignore that. The degree of a polynomial then is similar. It's the sum of its variable exponents. I'm going to put dot, dot, dot. So it's the sum of its variable exponents of its highest term. Highest term. Let's see if Miss Burry can spell today. There we go. So sum of its variable exponents of its highest term. If we go ahead and look at the second example, we've got a, b, and c, but it's clearly still a monomial. So this would be one where I would go ahead and say that this is 1, 2, 3, a 3-degree monomial. This last one, however, is a polynomial. So we are going to look for the sum of the variable exponents, but only of the highest term. So I'm going to go ahead and say this first one, my 8 and my 4, this is 12. Second one is 3, doesn't really compete. But the last one would be 13. So of the 3 terms I have here, I'm going to take the highest term, this 13. And the sum of its variable exponents are 13. So this is a 13th degree polynomial. That is it for your vocab lesson today on polynomials. Let me know if you have any questions.